Hello everyone, welcome back. Before we begin, look around you and pick any one object. Here's the question: why doesn't it just fall into pieces? Why does it stay as a single object? Let's find out. Everything around us is made of tiny particles called atoms. Atoms are incredibly small, but when they come together, they form everything we see: solids, liquids, and even us. We are now going to find out why atoms bond. So, atoms really don't bond because they want to, but they do so because they have to. To understand why, we need to look at the structure of an atom. At the center is the nucleus made of protons and neutrons. Around it are electrons arranged in layers called shells or energy levels. The shell closest to the nucleus is the first shell, then comes the second shell, then the third, and so on. But here's what really matters: not every arrangement of electrons feels the same. Some arrangements are calm, while the others are restless. Atoms are most stable when their outermost shell is full. For many atoms, this means having 8 electrons in their outer shell, with a pattern known as the octet rule. When the atom's outer shell isn't full, the atom becomes unstable. But nature wants atoms to be stable, not unstable. So atoms bond for the need of stability. They bond by giving electrons away, or taking electrons in, or by sharing electrons. They are all different methods, but for a common cause: stability. Till now, we have seen what causes instability in atoms. But we have come to a deeper question: how reactive is an atom? To answer that, we must first understand how far an atom is from stability. We know that octet rule says atoms are stable when their outermost shell has 8 electrons. But what happens when an atom has 1 or 7 electrons? Well, we now start reactivity. If an atom's valence shell has 1 or 7 electrons, it is only one step away from stability, as it can gain 1 electron or lose 1 electron to have a complete shell. Since losing or gaining 1 electron is easy to do, the atom reacts quickly. If an atom has 2 or 6 electrons, it is 2 steps away from stability and has to gain or lose 2 electrons to be stable again. But having to work with 2 steps is a bit more difficult than to work with 1 step. In this case, an atom with a valence shell of 1 or 7 electrons is more reactive than an atom with 2 or 6. And atoms with a valence shell having 3 or 5 electrons is even less reactive. And atoms with 4 are the least reactive, but not completely stable. It's just that they react much lesser than atoms with different sets of valence electrons. Reactivity is basically how easily an atom can become stable. If it's very easy, like when having 1 or 7 electrons, the atom has high reactivity. If it's harder, like having 4 electrons, the atom has low reactivity. So now we know that atoms don't react randomly. They react based on how easily they can become stable. But that brings up a bigger question: how do atoms actually achieve that stability? Do they give away electrons or share them? Well, that's what we are going to explore next. Thanks for watching, and if you found this helpful, consider subscribing for more.